Okay, good morning. This lesson is going to tackle more exponential equations, and they're going to tackle exponential equations that cannot be solved by writing each side as a power of the same base. So there's a couple of things that I'd like to do at the beginning of this lesson. This lesson is going to take 2 days, this class and the next class, in order to cover everything. Don't be put off by the amount of homework. It looks like a lot of problems, but it's not. Just trust me, it's not a lot. So one of the things I like to do when introducing this lesson is I like to put an equation like this on the board. So we have 8 to the x minus 4 equals 6.3. And just kind of like poll you guys on that, like how many of you can solve it. Probably none of you can solve it. I don't like how that looks. There we go. That looks better. Probably none of you can solve it unless you are doing this for the second time. You've covered this material in another course. And give you this info. By the end of this lesson, okay, which is 2 class periods. So in a block schedule, like where we have 90-minute class periods, it's 1 class period. And I usually tell students by the end of this 90-minute class period, you will be able to solve this and tell me it's easy. Okay, so I kind of want you to take a mental image of that, or take a picture of that if you're watching the video. If you don't believe me that you will be able to solve 8 to the x minus 4 equals 6.3 and tell me that it is easy to solve, then, okay, like then I actually don't have anything to say after that. But I am completely convinced that most of you will be solving that, and you will also tell me it's easy. Now, in order to do this lesson, you do need to have a calculator. So if you've been using your cell phone as your calculator, I'm going to tell you straight up that is a terrible calculator to use. Your phone will function as a calculator, but it is not designed to be a calculator. It is designed to be like a multi-purpose handheld computer. And so while it does a lot of things and it does a lot of things really well, it's just kind of a so-so calculator. So you need to get your hands on an actual calculator. I've got a couple of videos that I uploaded to YouTube last year when I did this lesson when we went virtual, and I'm going to link you over to those videos that will show you how to use your calculators specifically for solving these kinds of problems. So we're going to start off with this problem here. So consider this equation: 3 to the x is equal to 10. And if we're doing this in face-to-face, we're going to stop and talk about it. If we're doing this via video, I'm going to pause the video at this point, and I'm going to let you think about this. What can you tell me about x? Okay, what can you tell me about the number x? So x is some kind of number. What can you tell me about it? So we'll pause the video and let you guys think about it for a few minutes, and then we'll come back and kind of summarize it. Okay, this is always awkward to do in a video because some of you, we're going to do this in DHR, and so we're going to talk about it like live through the Teams meeting, but some of you might be watching this on your own after the fact, or watching it again for some reinforcement, or you missed the online lesson, or you missed the face-to-face lesson, or whatever. And so I do want to address some of the things that tend to come up when we talk about it. First of all, we can't write 10 as a power of 3. Because we have 3 to the first power is 3, 3 squared is 9, and 3 to the third is 27. And you'll notice that we skip over the 10. We want 3 to the something is equal to 10. So if I set it up like that, it might make it a little bit easier for you to see that x has to be between 2 and 3, because you're jumping over the 9 all the way to the 27. So if x is equal to 2, you're going to end up a little bit low. If x is equal to 3, you're going to end up a little bit high. And so you know that x is between 2, and 3. Now, honestly, sometimes when you're doing a multiple choice test, that could be enough information right there for you to answer the question correctly. So we don't want to snub how valuable it is to be able to look at the problem and reason your way through that. Sometimes students will go a little bit further and they'll say x is closer to 2 than to 3. And that is because 10 is closer to 9 than it is to 27. And so if you had to choose multiple choice and you had 2 options that were between 2 and 3 and one of them was closer to 3, you would know that that would not be the correct option. Now you could solve this equation by doing trial and error. So if you know that x is between 2 and 3, you could dump into your calculator 3 to the 2.5 and you would get some number for 3 to the 2.5. Let me see what that is. 3 to the 2.5 and you get 15.6. Okay, which is still too high, and then you could go a little bit lower and you could trial and error your way to the correct answer. But basically that's going to take a long time, and it might take a really long time if you need to get it to a specific accuracy, like if you needed to get it to say 4 decimal points accuracy, not just like 1 decimal point accuracy. And so bottom line is we need another way to be able to solve this equation. We need another tool in our toolbox. And that tool is the logarithm. So we are introducing today the logarithm. It is one of my favorite things to teach in Algebra 2. I'm not a huge fan of Algebra 2, but I do like logarithms. So we're going to introduce logarithms as a tool for solving exponentials. They're actually the inverse of exponentials. So we recently finished a unit on that included inverses, where you have inverse functions that undo each other, and the actual relationship between exponentials and logarithms. Exponentials and logarithms, yeah, that's neatly written, is that they are inverse functions of each other. But the way we're going to approach it in this particular lesson is we're going to approach logarithms as a tool to solve exponentials. So I have a really key idea here that you need to memorize. You need to have this like locked into your brain so well that you don't forget it, at least that you don't forget it until after you're done with Algebra 2. And then when you encounter this again in pre-calculus, it'll come back to you fairly quickly because it's going to be ingrained in your brain really, really well. And that is this. So we have our key idea. If you have a base raised to an exponent, and that is equal to some number or expression. And then I'm going to do like a 2-way arrow, okay? That can be written as log, and then whatever number is the base of your exponential is going to be what's called the base of the logarithm. Whoops. That number is going to be written smaller, and just to the right and just below, it's called a subscript. So where an exponent is called a superscript because it's written a little bit above. This number here, this base, is going to be a subscript written a little bit lower, kind of like in the slope formula where you have y sub 1 and y sub 2, and you use those little subscripts. The number or expression that's by itself is going to be what's called the argument of the log. And then the exponent is going to be over here by itself. So I'm going to actually pause even within the video and let you write that down. In fact, I'm going to do one other thing with that, but I'm going to pause the video to do it. Okay, what I did right there was I just recopied the line that I already had. I just color coded it because I'm big on coloring. And so I just like colored the B in red so you can see where the B goes. So the B, which is the base of the exponential, becomes the base of the logarithm. The E, the exponent, is in green, so that's going to come over here by itself. And then the N, which is by itself in the exponential, becomes the argument of the logarithm. And that's how you go back and forth between logarithms and exponents. It's a low-level skill, okay? It's not a high-level thinking skill. It doesn't require a lot of like decision-making and critical thinking. It just requires some straight memorization of which number goes where. Now, before we leave this, I do want to go over how we say these things out loud, because the words that we use do matter. And I'm actually right now partway through grading a college algebra test, and I'm having to take off points because people are saying things that I know what they intend to say, but they're saying the wrong thing. They're saying something different. And that happened on your last test as well. Or at least we haven't done the inverses test at the time that I'm grading this, but where you would say like opposite sides, which mean opposite sides of an equation, but you use it to mean numerator and denominator. So using the wrong word choice, and you end up saying something that's not what you meant to say. So this on the left-hand side, we would say b to the e equals n. Okay, so the way you would say that exponential, you say b to the e equals n. On the right-hand side, this is read out loud, log, and then you actually say the word base. So you say log base b of n equals e. And so you say log base b of n. So a log is something that you're doing to a number. It's an operation that you're doing to the number. It's not multiplying there. You are doing something called taking the log. And I really, really want to be clear with that, because otherwise, if you misunderstand the way we're writing it and the way we're saying it, what you'll end up doing is trying to like factor logarithms, and you can't factor logarithms because factoring undoes multiplication, and it's not multiplication. So it's really important that you understand what's happening there. This is log base b of n equals e. And if you are saying it out loud to me, I don't want to hear like log bn. I want to hear log base b of n, because that is the correct way to say it. So the first set of exercises is just changing from one form to another. It's just getting practice rewriting your exponents as logs. So we'll go back to that example that we started with. If you have 3 to the x equals 10, and you were asked to rewrite that as a logarithm, it would be log base 3 of 10 equals x. And so all we're doing is making sure we put the right numbers in the right places. So we had 3, and so the 3 becomes the base. We had 10, and so 10 becomes the argument, and x was the exponent, and so that was over there by itself. So log base 3 of 10 equals x. Again, notice how I'm saying it. Next example is 2 to the 3x plus 1 is equal to 20. And we want to remember that math is awesomely consistent. So just because the exponent looks yuckier doesn't change anything about the key idea that I just gave you. I gave you a key idea. The key idea is the key idea is the key idea. It doesn't change just because something in the problem starts to look more complex. So to change this over, we would have log. The base of the exponential is going to become the base of the logarithm. So we would say log base 2. The number over here by itself becomes what's called the argument of the log. So log base 2 of 20 equals the exponent, which in this case is 3x plus 1. So don't let the fact that the exponent is yuckier looking throw you off. Math is consistent. All right, last one we have. This one is kind of a cool one. This one is going to engage a couple of different skills. So we have 5 to the 2n minus 3 equals 18. So we have a little bit of a problem here. If you look at the way this problem is set up, we have 5 to the 2n, and then we have a minus 3 that is not part of the exponent. And I'll kind of wait for a moment so that you can let that sink in. And I'll choke on a granola bar or something. I don't know why I'm choking. And if you did write it as part of the exponent, you should erase it or rewrite it so it's not. Now here's the problem. My little key idea that I gave you over here does not have any +3 or -3. There's nothing in the exponent. You've got a base raised to an exponent equal to some kind of number or expression, and there's no +3. And so you can say something like this. Don't write this down. Log base 5 of 18 equals 2n. And I'm going to ask you, what did you do with that 3? Where did that 3 go? And the problem is that there's no 3 in that template. So we need to deal with the 3 before we can change it over. And this is not new. You guys know how to undo a -3. You undo subtracting 3 by adding 3. Because math is consistent. So the same things that have worked forever for solving an equation, undo subtraction with addition, those still work. So now I have 5 to the 2n equals 21, and now it fits my key idea over here where I have something raised to an exponent equals something else. So we'll go ahead and change that over. Log base 5 of 21 equals 2n. So that is the first skill, and if you're a little put off by your homework, I'll just point out that like some of the first problems, like this is all you're doing, and it's just something that you need to practice. This is not a high-level skill. Like I said, this is just rearranging the numbers and making sure the numbers get into the right spot, and so you just need to rewrite it enough times so that it sticks in your head. So I'm going to go ahead and put some practice up here. And all you are going to do is rewrite them. So here are the 3 problems. 7 squared equals 49. Hopefully you know that's a true statement. 8 to the 3p is equal to 20. And 6x and then a +2, but the +2 is not in the exponent, equals 12. So I'm going to pause the video at this point and give you a chance to write those in. It's kind of hard to participate online with this because of the subscripts and stuff. It's a little hard to write out what you intend if you're typing on Teams or something. So we'll just pause the video, give you a chance to do that, and then I'll put the answers up next to it. Okay, so here are the answers so you can check your work. You should have log base 7 of 49 equals 2, which is also a true statement. We haven't gone through like the properties of logs. We're going to do properties of logs after your EOC because that particular material is not on your EOC, but that is also a true statement, just like 7 squared equals 49. Log base 8 of 20 is equal to 3p. Now for the third one, you need to subtract 2 from both sides, and so when you do 12 minus 2, you'll get 10, and you should have log base 6 of 10 is equal to x. So hopefully you feel pretty comfortable with that. And again, just need to do enough of it. If you do not practice this while it is fresh in your mind and while it's still the same day that I'm teaching it, I can almost guarantee you that by the time you take a quiz or a test on this, that you will switch where the numbers go. You're going to get the numbers in the wrong spots because you're just not going to remember it well enough. So this is, you might think, well, a big deal. Okay, so you can switch the writing around. If you don't know what log base 8 of 20 is, that doesn't really get you any closer to being able to solve your equation. So what we are going to do is use your calculator, and you do have to have a calculator for this. This is not something that you are going to be able to get around. So we are going to use the calculator. My mom is messaging me. She is home from the dentist. Calculator. And then she's going to watch this video and say, I can't believe you said that. Use the calculator to evaluate the logs. Okay, and you can say logs instead of logarithm. That's totally fine. And here's our second key idea. This is called the change of base formula. And here's the deal. Your calculator, or some of your calculators, depending on the calculator that you're using. So a scientific calculator, some of the more basic scientific calculators, and some of the more basic graphing calculators will only evaluate 2 kinds of logs. they will evaluate what's called a common log, which is a log base 10. So I'll kind of put that over here. Log base 10 is called a common log. And that is assumed if you don't see any base written. So if there's no base written on the log, it is assumed to be a common log. The other kind is represented by an ln, and that's called a natural log. We will cover natural logs right like at the end of this unit, and it's nothing, okay? It's just like, it's the same as everything that you learn for every other kind of log. But your calculators, for the most part, will not do log base 8. So if you want to figure out what log base 8 of 20 is, your calculator doesn't actually do it. Now, a couple years ago, I lent my graphing calculator to Mr. Frenzel, and he ran an update on it. So now my calculator does do log of different bases, and some of your higher end scientific calculators will do logs of different bases, but I cannot presume that you all have access to that kind of calculator. And if you are hopping onto the internet to try to use a calculator, which you should not be doing, you should own a calculator, you're definitely going to have trouble finding what you want there. So here's the change of base formula. If you have the log of some base of a number, that is equal to the log of whatever the number is divided by the log of the base. Now, here's how I can help you remember this. Think of the B as being in the basement. It's the base. It's down below. What's down below? The basement is down below. The A is up higher. We'll call it the attic. We're going to bump the A up to the attic and the B to the basement, above, below. So the log of the attic divided by the log of the basement. There's your change of base formula. So I'm going to do some calculations. I'm going to do some examples so you can see how this works. And we're actually going to go back to we're going to do a couple. We're going to do this one right here, log base 3 of 10, and we're going to look at this one, log base 7 of 49, which we know the answer is going to be 2, okay? And so our calculator should give us a 2, and then for some reason I have another one. Oh, I know, I'm going to change one up from the notes. So if you're looking at the scanned notes on Teams, I'm going to change one up just because it's one of those things that I kind of fell into a pattern that I did not intend to fall into. So we're going to do log base 3 of 10. So most of us don't have calculators that will do log base 3. Now, if you do have a calculator that does log base 3, yay, that actually is going to become an obsolete skill at some point because all calculators will do it. But we're going to take our attic number, which is the 10, and we're going to do log of 10 divided by the log of our basement number, which is 3. And then this goes into your calculator. Here's the rub. Every calculator is going to be a little different. So I'm sitting here with my graphing calculator beside me, and the way I'm going to do that is I'm going to find my LOG button. So you want to go look at your calculator, find where you have an LOG. Okay, it's on there. As long as it's a scientific calculator, it's on there. If you're using a for function, it won't be. I'm going to do LOG, and then I'm going to type in a 10, close the parenthesis, hit my division symbol, hit log, LOG, 3, close the parenthesis, hit enter, and that is going to give me my answer, which is 2.0959. When it comes to rounding, you always want to round to whatever the directions say for you to round to. Okay? Now, every calculator is different. So for some calculators, you're going to hit 10, then log, then enter, then 3, then log, then enter. And without me seeing what kind of calculator you were using, I don't know what to tell you to do. So if you are in my DHR section and you are having trouble figuring out your calculator, please let me know. I'm also going to link you over to some YouTube videos where I demonstrate some different calculators, okay? If you are in a face-to-face class, we'll iron it out in class. Second one we're going to do is log base 15 of 5. And if you look at the notes, I had log base 5 of 15. And the reason I switched it is because I don't want you to always think that the base is smaller than the argument. So we're going to do the log of 5, the attic, divided by the log of the basement, which in this case is 15. So I'll have log of 5 divided by log of 15. And I get 0.5943. And another thing that students do tend to struggle with here is the rounding. So if you aren't sure if you're rounding correctly, please let me know. I can do a little tutorial on that. Please don't be ashamed of saying that you don't know how to round either, because it's super common. All right, log base 7 of 49 is, we know the answer should be 2. So we'll do log of the attic, which is 49, divided by the log of the basement, which is 7. And I know what the answer is, but I'm going to go ahead and do it anyway. This can confirm to you whether or not you're using your calculator correctly. So if you're getting some other number out for that, if you're getting some other number, you know that you're not hitting the keys in the right order, and you need to figure out how to hit the keys in the right order. All right, so let's look at some practice. Take your calculator, whatever your calculator is, and I would like you to find me what log base 3 of 81 is and log base 6 of 4. Now this is strictly a calculator exercise. It's learning how to use your calculator to make sure you are getting the right number out. So we'll pause the video. I'll give you guys a chance to do that. We might do the answers online. I don't know. And then we'll go over them together. And here are the answers. So you should have gotten 4 for the first one, and then 0.7737 for the second one. Okay, and again, don't be freaked out by your homework because a lot of the problems on your homework are just this. They're just getting the practice. So what we have left to do is to put all of this together so that we can solve the equation from the beginning. And you might already even have some ideas for how you could solve that equation. So you're welcome to try, and we will resume with this next class.